We're back, year 3 of the IoT Solutions World Congress. I wanted to, again, welcome you and thank FIRA Barcelona for the great show and for the Industrial Internet Consortium for doing such a great job. So, for those of you that have been here before, you're back for a reason. This is simply the best show on the planet for IoT, and if you're new, you're going to experience, I think, something special this week, so welcome. I've had the privilege of talking to this group over the last couple of years, and this chart is something that I've used every year to really represent the journey that we're all on and the mountain of opportunity that exists in IoT. And really, it starts with connecting the unconnected and then evolving to intelligent, interconnected systems and eventually getting to a position of software-defined autonomous machines. And what you're going to see out on the show floor, and hopefully in a couple of examples today in this talk, are reflective of all three of these states that are happening simultaneously, depending on various customer use cases and various industries. And so what we thought we'd do today is, rather than tell you about the journey, which we talked about last year, or what IoT is, which we did in year 1, we thought we would talk about really what's on everyone's mind, which is, how do we get scale? How do we drive repeatability? How do we embed security and really harness the entire ecosystem to deal with some of the scale barriers that exist to IoT deployments? Because we're seeing a lot of growth in the industry, but I think everyone wants to go faster. So what I'll share with you today are really a couple things. The first is we'll reflect back on the past year through a scorecard of sorts and see what kind of progress we're making and what are the things that are really driving the industry forward. Secondly, we'll talk about some examples of what's happening. We'll use smart cities as a proxy for what I think is happening across a variety of industries and give some real-world case studies. And then we're going to get into the scale barriers and talk specifically about what Intel and our partners are doing to get past these barriers and make it really easy to deploy IoT technology at scale. Sound good? All right. So, the leading indicators. There's really no scorecard that exists to talk about the progress of the industry. We look at it from various lenses, whether it be, analyst points of view or case studies, et cetera. And so last year I introduced this simple scorecard, which really looks at 3 vectors. We look at the technology, we look at economics, and we look at people. And this is not scientific, but it certainly, I think, is a directionally correct view into the progress we've made over the last year. And so this year, I have chosen some things that I think are pretty interesting, and hopefully you'll agree. So we'll start off with worldwide growth in data. So what you see on the left is the growth in IoT units. You can see they're growing at 16% CAGR. This is, of course, data from IDC. And I think we all know that, whether the number is 20 billion or 30 billion, it's big. And it's happening, and we're actually seeing the growth materialize as we expected. We're also seeing that the amount of data is significantly growing. So over the next 8 years until 2025, we're going to see a 10x increase in the amount of data on the planet. And what's interesting is that 17 times growth in IoT data certainly is a lot, and it's growing faster than the consumer internet and other categories. But what I find fascinating is that the real-time data in IoT is growing 40x over the next 8 years. And IDC believes that over 40% of IoT data is actually being processed at the edge. Now, this may be contrary to what we have been thinking over the past 15 years, because over the last 15 years, everything's been moving to the cloud. Now we're saying almost half of it is happening at the edge. I'm confused, but not really, because we're going to talk about that in a second. So first of all, I want to thank IDC for this chart. Vernon Turner, if you're in the audience, I will buy you dinner tonight. Thank you for allowing me to use this. There's a lot of things that are driving IoT processing at the edge. One of them is the tremendous advancement that we're seeing in artificial intelligence. And what you're seeing here is really advances in both image or video-based AI as well as speech recognition. And what's happened over the last 7 years is that we have gone from really bad computer vision and speech recognition to exceptionally good in a remarkable period of time. And right now, AI for video and computer vision analytics and speech is now better than humans, and it's happened remarkably fast. And you can see here on the upper right that now we not only have the ability to just do object recognition, we have the ability to follow objects and to track them, and to do that in a variety of conditions, such as low light, or when things are partially covered, when they're moving. And this is especially good for things, for example, in smart cities, where you don't necessarily have control over all of those environmental conditions. And of course, Intel's investing in technology to make this work really well. You may have heard of a company called Movidius that we picked up last year. This is a vision processing engine. It's an accelerator that allows you to put this compute out at the edge in a camera to be able to perform deep learning capabilities on the edge in very low power and low footprint cases. So here's Gartner's chart. And you can squint and find your favorite AI trend on this chart. But it's AI, and it's the processing of AI that's happening out at the edge that's driving a lot of this data and a lot of this use case. And I like to think that in high tech, in the technology industry, we tend to overestimate how quickly things will mature. But we always underestimate the impact that that technology will have on the world, and I think AI is another great example. We've talked about speech recognition and image analytics, but as you can see, AI is gaining traction across a whole variety of IoT categories. We have farmers that are using, as you heard Sam George talk about in the Schneider Electric use case in New Zealand, that are using cameras to identify not only what part of the crop should be irrigated, but also doing it to do crop inspection to identify if there's disease or infestation. It's being used obviously in autonomous driving, one of my favorite use cases for IoT, and I think that the acceleration that we've seen over the past 7 years in quality and accuracy is going to apply overall to the AI industry, and we're going to see this move faster than anything before. So here's where we've come from. The last 15 years has been all about cloud computing. And there has been this general belief, I dare say a fallacy, that all network compute and storage would move into the cloud, and with it, all of the data and analytics, and therefore value would reside there, and the edge would be just a dumb data source. Now, that, I think, has been some people's perception of how this market was going to evolve, but it couldn't be further from the truth. And as you've heard Schneider and Microsoft talk about this morning, what we're seeing is that IoT demands edge-based compute. There are applications and use cases that require, for a variety of reasons, that we have an end-to-end distributed computing architecture where value will be created at the edge, in the network, and in the cloud. And it's that integration of and workload optimization end-to-end, which is where the industry is going. And there's a variety of reasons. I mean, we talk about video being a use case. You're certainly not going to take a live video stream from thousands of cameras in an urban environment and move that to the cloud for reasoning and then send back some response. You want to do object detection and alerts and certain capabilities on the edge because the bandwidth required to move that is just too great and the cost too high. We also have cases where you need to get latency down to a nanosecond level, such as in robotic manufacturing applications. You need to have it happening locally in as close to real-time responsive nature as possible. So this is where we believe not only the future is, we believe it's happening today. So that was kind of a little brief on what's happening in technology. Let's talk about what's happening economically. Here you see the explosion of investment in artificial intelligence companies over the last several years, just the last 5 years. Now, this is just a subset of all of the investment that's happening in IoT, but I think it's a good lens into just how significant this will be. Last year, I showed you all of the acquisitions and mergers that had taken place in the industry. This year, I think it's important to talk about the investment. The number of deals in the past year is over 600, and over $5 billion of venture investment going in. This doesn't even include the amount of money that's been spent on acquisition. For example, you see here we list Movidius and Nirvana. These are two companies that we acquired. We did not list on this slide Mobileye, which is a company that we acquired, an Israeli-based computer vision company for autonomous driving, which would take this chart well over 15 billion. So what we have here is we have companies like DataRobot. DataRobot is a machine learning platform for data scientists. We have Matroid, which is a company we recently invested in that is basically a graphical user interface for democratizing deep learning algorithms. They call them detectors. Mighty AI is a training set for deep learning to be used in a variety of industrial use cases. And in total, Intel Capital, just in the past year, in the past 3 years, has invested over $1 billion in these seed companies. And today, we're going to add another company to the portfolio, which is Foghorn, who I think has one of the most cleverly named companies in tech. And we're going to participate in Foghorn's Series B. If you're not familiar, Foghorn is a machine learning and analytics solution for on-prem and industrial commercial IoT apps. So we're excited to welcome them, and congratulations to David and his team. But with great power comes great responsibility, and you heard Sam talking about security and how data centers are secured with armed guards, but we have all of these devices at the edge, and how do we keep them secure? I think, anytime you have an increase in the number of nodes, you're going to increase the potential vulnerabilities, and IoT is a great case for that. We saw last year the Mirai attack, which was the single largest attack in internet history, which took down a large portion of the American internet. And the cause of this was simply user error, really. It was a human error, because what allowed that attack to happen were 200,000 IoT devices that were compromised and were then used to take down an ISP with a denial of service attack. So what you see here is growth in IT security spend, which is growing at 20% CAGR, which is great for Silicon Valley security companies. It's not great for customers, but what it signifies is that we know that security is important. In fact, it's the #1 barrier to scaling, and we need to do something about it. And so what we're going to talk about this morning, and one of the announcements we'll make, is really what we're doing to improve security in IoT and to make it really, really easy for people to do so. So how are companies trying to keep up with these AI and security trends? Well, one thing they're doing is throwing people at the problem. And so we thought it would be fun just to see who's hiring. And so we looked at 5 companies, and you can see them listed here. And we just did a search on IoT security jobs and AI jobs. And this is as of a couple days ago, over 5,000 positions available today at these 5 companies in AI. It's just extraordinary. And it's a really good time to be an AI engineer. So for the folks that were data scientists a couple years ago, this is your next new thing. All right. Moving on to smart cities. I think smart cities is a great proxy for what's happening in pretty much every industry, because you've got all of these various environmental conditions and technology requirements that are, I think, impacting the world. And we're also seeing that, the cities are growing. Urbanization is real. Just in the past 9 years, we've added 100 cities with over 1 million people. And the irony here is that it's technology that's driving people to cities, and it's technology that's making cities challenging. And you can see here that cities produce as much as 80% of, or consume as much as 80% of global energy, and produce about 75% of the world's emissions. And that's technology that's causing those issues. And you can see here that on average, people are spending about 50 hours a year sitting in traffic. So the technology of automobiles and transportation is creating that issue for us. And with this pollution created by these, we've got 2 billion people with poor air quality. In fact, 10 people per minute die from poor air quality, and we don't talk about this. In fact, more people die from air quality than from major diseases, from terrorist attacks and other issues, but there's not a lot of public outcry about air, and there should be, I think, because it impacts our lives, and it's not going to get better if we don't address it. So I think technology can help. Bosch is a company that Intel's been partnered with for a very long time, and we're extending that partnership to include how we can change people's lives through the air that they breathe. And so I'd like to welcome up Senior Vice President of Powertrain Electronics and Power Engineering, R.K. Shenoy. Shenoy, thank you for coming. I want to thank you for the great partnership. I brought my own air quality monitoring station. Yeah. I wanted to impress you. So if you don't mind, let me give you a tour. I'll take you inside and show you this, because I think it's super cool. So this air quality monitoring station is actually a fraction of the size of...
The actual station is around 8 times this.
8 times this. So it's actually like it's like a container.
It's a room where a lot of people sit and actually need to measure the air quality and work on these instruments to actually know what the air quality is.
So if you thought you had a really crappy cubicle, imagine coming to work in this thing, out in the middle of nowhere in some environment, monitoring environmental conditions. But we can do better than this, right?
Yes. This needed experts to operate, and many of them are actually not even connected. So what we did in the partnership is actually develop something, string the whole thing, this room, into something fabulous. This is our microclimate monitoring system from Bosch, developed in partnership with Intel. And this is the one which we believe with IoT can actually enable and measure air quality across the city.
So we actually took an air quality monitoring station.
Correct, which is 8 times the size.
And we made it 1/100th of the size physically and 1/10 the price.
1/10 the price, 1/100th of the size. That's right.
And can you tell, thank you, someone appreciates that. Can you tell us a little bit, before I fall out of it, what it does?
Yeah. This, as you see on the map here, we have deployed this in many cities all over the world. Specifically, if you go to one of the cities in Pune, you'll see that there are around 50 of them deployed, and you're able to do a heat map of a city like this. You're able to see the AQI, which are the parameters seen there. That means there are times in future where people will decide which part of the city to live in, because we're able to do a heat map of the whole city based on the units like this. If we go deeper into next level, you'll see that we have installed one of these units here in Barcelona, and that's the AQI in Barcelona.
It's good.
It's much better. It looks green as compared to the yellow, what you saw earlier.
That's because everyone's on strike, and so there's no buses or anything going on. So I think, something did positive result from this.
I guess so. If we now go slightly deeper into next level of details, you will find the air quality parameters from various important gases. The NOx, sulfur dioxide, then you have the particulate matter, which is very important, and then you have ozone, temperature, humidity, noise, as well as light.
So this is an example of connecting the unconnected. We get access to data of our physical environment that we live in. Once we have access, what can city planners and governments do with this type of data?
Yep. Once you have a device like this, which can be deployed in multiple numbers, because of the small footprint and the low energy it consumes, we're able to collect the data across the city. And once you map it, you can define, for example, which part of the industry are there, which part of the city the traffic density may be high, or what other changes can be done in the lifestyle in the city, and how the green cover is there, etc. And then this measurement helps very much, because compared to these boxes, which every city could have only 2 or 3 of them, because of the large size and the cost, now you can deploy them multiple into the city and use this connected data.
It would seem like, there would be use cases outside of just a smart city environment for something like this.
Sure. We believe that this can be used also in industrial environment, for example, even in mines, and other environments like when real estate. When there's a new real estate coming up, you can use this also to decide which part of this real estate can actually be of much better quality.
I could imagine also companies would want to use this in their offices or potentially in
indoor too.
Manufacturing facilities.
Yes, in factories, in manufacturing facilities, and indoor too, because then you can decide what type of air is available inside and do air change sequences based on this measurement that's already done and connected.
Very cool. Thanks, Shinoy.
Nice meeting you. Thanks for the invite.
All right. I'm just going to close this one up permanently. So that was cool. Thank you, Bosch, for the great partnership. But this isn't the only solution that has really gained a lot of traction in the last year. If you were here in the second annual conference, we talked about a partnership with GE where we launched what's called CitiIQ. And this is an intelligent light post that not only offers an LED intelligent lighting solution, but is really a platform for all kinds of city services. It has cameras, it has sensors, it can do pedestrian detection, traffic monitoring, license plate detection, it has parking applications. It's really a transformational opportunity for cities to put these intelligent light posts in. And I thought I'd give you an update. It's been a year. How are we doing? Well, we actually have deployed the city of San Diego in the US. We've deployed Atlanta. There are actually dozens of other cities that are in the process of going through an evaluation or a pilot of this solution. And so suffice to say, it's going really, really well. And I think this is a great example of a smart city solution that's gaining traffic. And one of the things that I think is cool about it is that GE opened up their platform. They opened up the APIs to the developer community so that anyone can write an app based on data that's coming out of this platform. And there's actually a couple of interesting apps that I thought I'd highlight for you today. One of them is called Traffics, which is a pedestrian heat map. And that can be used for urban planners. It can influence traffic light timing and a variety of things. And there's one also leveraging pedestrian traffic and car traffic, which is called DreamBiz, which provides data to potential store owners to give them more information about how to better choose real estate based on the traffic flow. And then there's one if you're feeling very zen and you want to find a nice, quiet spot in a city. There's an app called Peacemaker, which will allow you to find, based on where the least amount of noise is in your general vicinity, you can find the nearest park or such. We also have a solution, this is in the Intel booth, by the way, called Parkion, and there's a Wind River event tonight where we're going to have a little street fair. Parkion is more than just a parking meter. So first of all, as you can see, it's solar powered, which is great, but it does a lot more than just allow you to pay for parking. It has, of course, a companion app that will alert you when you need to renew your parking and gives you other real-time information and timetables on things that are going on in the city. But again, similar to the GE solution, they've opened up their platform and have made their APIs available to app developers so that you can push a variety of different things to the touchscreen on the Parkion. And for cities, this is great because now they have the ability to remotely monitor these parking stations. They can identify when they need to be emptied of money. They can identify when they need to push a software or security update. There's all kinds of things that can be used to inform maintenance information. We also launched a smart fire truck this past year, which I think is a really cool use case. So this is with a company called Waterous, and Waterous makes foam and water pumps for fire trucks. In fact, they've been doing it since the 1800s, and we partnered with Waterous, leveraging Wind River and Helix Device Cloud to essentially put a touchscreen on fire trucks that allow firefighters to be able to monitor and adjust the amount of fluids that they're carrying in the truck, but it also gives the central fire station the ability to monitor their entire fleet of trucks across a variety of different sensor data so that they can manage at a fleet level. And they actually even integrate into the city infrastructure so that you can get an idea based on how the city is monitoring water pressure in various parts of the city. They can tap in and integrate into that data. All of this is done with a single touchpad, and of course it was Intel and Wind River's experience in automotive over the past 15 years that gave Waterous and their customers confidence that we could integrate an electronic system and electronic controls into their mechanical environment, which of course has to be fault tolerant. So there's a lot of scale barriers to IoT. We talked about talent, we talked about ease of deployment. I'm going to spend a couple minutes talking about security and market-ready solutions, which we think are dramatically going to change scale in the industry. So we talked about the Mirai attack and how that happened with default passwords. Another way that IoT devices fail is the manual device provisioning process, which is getting that device on a network, connecting it to a cloud service provider, establishing the security credentials, and all of that configuration. It's very time-consuming, and it creates potential vulnerabilities because you've added a human to the process. Also, if you're not maintaining the software, and again, creating an opportunity for a hacker. And then we believe that security is best when it's deep in the stack, as low and embedded into the silicon as possible, which is why for the last several years, Intel has been leading what we believe is more of an industry-wide solution around enhanced privacy ID. And so we've licensed our technology to other silicon manufacturers to put security below the operating system where it is most effective. We call this the Enhanced Privacy ID, or EPID for short, and this is a key part of what we're going to announce today. So a question for you, or a joke, which is, how many IoT developers does it take to change a smart light bulb? And the answer should be none, or one, because it should be automated. And right now, whether it's a light bulb or it's any other device, it takes 20 to 30 minutes to configure a single IoT device. And there's no way we're going to get to the scale that's going to happen in the marketplace if we don't automate that. So that's exactly what we're going to talk about today with this announcement of Secure Device Onboard from Intel. So Secure Device Onboard is something that we did with the ecosystem. This is not about us per se. This is about an ecosystem of partners. And what it enables is zero-touch, near instantaneous, highly secure onboarding of IoT devices. And so when you have a processor that's provisioned with this enhanced privacy ID capability, it's turned on. The Secure Device Onboard application enables it automatically, securely, and without any password. So when you think about what happened last year with the Mirai attack, people didn't change the password of their IoT device, and so it was easily compromised. In the future, there will be no password. There will be no username, because everything has a unique identifier in the silicon, and so you remove the human from this process. So as you move across the chart, this Secure Device Onboard will then allow the device to connect to any device management service, whether it's from Wind River or Device Authority. And what that allows it to do is not only authenticate it, but it allows you to automate the software update process and onboard it then to the last bubble, which is any IoT platform, whether it's Google Cloud Platform, Microsoft Azure, or Amazon Web Services. And what's cool about this is that usually like adding security to something slows you down. In this case, this actually speeds you up, increases the amount of security you have and ROI at the same time. So our first customer for this, one of our first customers, is a company called Weatherford. That's one of the largest oil service companies. And we've been working with them for the better part of this year to integrate secure device onboard into their system. So I'd like to welcome their Director of IT, Colin Tate, up, and we're going to quickly tell you about what we're doing here with Weatherford. Colin,
nice to meet
thank you for coming. I brought an air quality monitoring station. You brought an oil pump.
An oil pump.
Well done.
This here's a maximizer. This is a workhorse of the oil and gas fields. This is only one type of equipment that we have deployed. There's many different types of equipment, and they're all typically, they're not in holiday spots. They're in remote locations. Oil fields are dangerous places, so it's typically we go from hot to cold. Many different types of environmental actions affect this equipment, so we always need to ensure that it's in working condition.
So these are in remote locations. Just give me an idea. How many oil wells are there?
So oil wells in the US, we've got about 1 million of them.
So there's 1 million oil wells in the US. All of them are going to have some instrumentation and equipment.
They all, to produce oil and gas, you've got to produce it safe. You must have equipment there to monitor the fluids coming up, and also to ensure that the whole environment can be safe and clean. That means that we must monitor this at all times. One of our key visions is to create a digital oil field, both starting from drilling straight through to production. We have Foresight, which is a production optimization platform that uses advanced data analytics, and the key there is that we can now give operators the chance to basically manage their destiny, manage exactly what their maintenance schedules are, and also increase the reservoir potential.
So what you really need then is the ability to access potentially 1 million oil wells remotely. That would be probably a pretty convenient thing for you.
Obviously, we're not going to do them all. That would be our dream. However, you've got a pump jack here. You've also got tanks. You've got multiple different types of equipment. Everything needs to be monitored. That is one of the reasons why we came to Intel.
And created this cool box. So tell us what this box does.
So this here is our gateway. And the key here is consistency, accuracy, and also safety. We want to put these on equipment such as this or other surface equipment, get the data, take it here, and then send it to the cloud.
Cool.
But the real value here is the secure device onboarding. Because right now, we don't want people, when they go, technicians here, to worry about, is it this cable, is it that cable? We want consistency. All you've got to do here is plug in the network, plug in the power, and that's it. And the other key is our hardened security, which is on board. And that is, we do not want our customers to feel that these areas could be compromised.
So I would think this would be really important for your customers, because they probably send out contract techs to install these types of devices, and you don't want to have to train them, and you don't want to have to compromise security. So all they have to do is to install this device is plug it in, and all of the provisioning, the onboarding, the security is all automated. That seems like that would be a very scalable solution.
That's a key. As you can see from this slide, we've got multiple different types of areas that we must go to. Apart from the remote locations, we must have a way that we can go away and make this as simple as 1, 2, 3. That's what Intel provides us. Intel has provided us the ability to ensure that we've got hardened security on the device at a low level. We don't have to go away and carry passwords around. We plug it in and it's done. It's
Great.
simple.
Colin, thank you so much.
Thank you very much.
All right, take care. Thank you for that. So as I said, this is about the ecosystem. Here you can see that we have partnered with other silicon providers to make the EPID, Enhanced Privacy ID, available through them, so the secure device onboarding service doesn't have to work exclusively with Intel, but can work with any provider. In fact, over the last several years, we have over 2.7 billion devices that are now enabled with Enhanced Privacy ID. So this is a scalable solution to solve a real security problem. We're enabling equipment providers, so no matter who your partner is, odds are that they will or either do or will have this capability to make your life a lot easier. And lastly, I would say that the IoT platform role here is critical, and in the Intel booth, as well as in their booths, you can see demonstrations of Google, Amazon, Device Authority, and Wind River, all of them here at the show. We're excited about that. And I just want to close with this idea of a market-ready solution, because I think any time in technology where the burden of technology choice and integration falls on the customer, that's a problem. So what Intel and our partners have been trying to do over the past year is to really accelerate the ease of deployment while doing it securely in a way where solutions are pre-integrated. And they've already been deployed and tested, so it makes it really easy for a customer to then adopt and absorb the benefits of these solutions. We chose to highlight 10 here. By the end of this year, there will be 50 of them. We're being very selective about which ones we allow to be part of this program. In fact, we have only a 30% acceptance rate. So you know that these are trusted solutions that you can rely on. By the end of next year, we'll double that. We'll have 100 market-ready solutions. And again, we're trying to make the world an easier place for IoT solutions. If you stop by the Intel booth, there's a lot happening in there. We basically have modeled it after a lot of smart city and industrial use cases. And I encourage you to stop by. So I want to thank you for your attention this morning, and have a great show. Cheers.